Previously we've spoken about the fact that the gradient is equal to 0 at the turning points. So it makes sense therefore that if we wanted to find turning points on a graph, we could find its gradient and let it equal to 0. But there is more than one type of turning point. Obviously there's a maximum turning point, a minimum turning point, and a point of inflection. So that is why we call them now stationary points. They all fall underneath that banner. The displacement x meters of a particle moving in a straight line is given by x equal to 9t minus 1/3 t cubed, and t is between 0 and 3 root 3, where t seconds is the time taken, and we need to find the maximum displacement. So what we're going to start off by doing, because we're talking about a maximum displacement, it would be at one of the turning points on that cubic. So let's find what is happening at that turning point. And the way we're going to do that is finding dx dt. So we're going to find the turning point. And so when we do dx dt, we have 9 minus 1/3 times 3 is 1, so minus t squared. So at the turning point, we know dx dt is equal to 0, so we're going to let dx dt equal to 0, and we get 0 equals 9 minus t squared. T squared is equal to 9, t is equal to plus or minus 3. So at the stationary points on this particular cubic, our value of t is positive or negative 3. What is the x value or the displacement value? So let's find when t is equal to 3, what does x equal? So x is equal to 9 times 3 minus 1/3 t cubed, 3 cubed. 9 times 3 is 27, minus, now 3 cubed is 27, and a third of that is 9. 27 take away 9 is 18. So if we had found when t was equal to negative 3, remember displacement is just the amount of distance, so we're not particularly worried about the negative or positive. So when t is equal to negative 3, what does x equal there? And it's 9 times minus 3 minus 1/3 times negative 3 to the power of 3, negative 27. Now negative 3 cubed is negative 27, and a negative times a negative is a positive. So 27 divided by 3 is 9, and it is negative 18. So the distance there, the total distance, the negative means that it's gone in a negative direction, but basically the maximum displacement is equal to 18. In this example, we're asked to find the stationary points of these functions. Again, we know that the gradient is equal to 0 at the stationary points, so let's use that as a starting point. dy dx equals 12 minus 4x, and we know that at the stationary point dy dx is equal to 0, so let's let dy dx equal to 0, and we get 12 minus 4x is equal to 0, minus 4x is minus 12, x is equal to 3. And of course we want the point or the coordinate, so when x is equal to 3, y is equal to 9 plus 12 times 3 minus 2 times 3 squared, which gives us 9 plus 36 minus 3 squared is 9 times 2 is 18, and we get 27. So the coordinate there, when x is 3, y is 27. And that is our stationary point. So there is only one stationary point in that quadratic, which is what you would expect. Let's try the next one. Now this time we've got p in terms of t, so we're going to do dp dt to find the gradient of that, and we get 6t squared minus 10t minus 4, and of course we're going to let dp dt equal to 0. Now the original was a cubic, so we would expect that there would be 2 turning points, or a maximum of 2 turning points. So let's have a look here, and we get 6t squared minus 10t minus 4 is equal to 0. Tidying that up, 3t squared minus 5t minus 2 equals 0. Factorising that, we get 3t and t, and factors of minus 2 would be 1 and negative 2, and when we go across our bridge we end up with negative 5t. So we have 3t plus 1 and t minus 2 equal to 0, and so therefore t is equal to minus 1/3, or t is equal to 2. Now, because in the original question we were told that t was greater than 0, we don't have to worry about the solution for t equal to minus 1/3. So let's just substitute in t equal to 2 into the equation. So p is equal to 2 times 2 cubed minus 5 times 2 squared minus 4 times 2 plus 13, and when you work that out you get 1. So therefore for this one our stationary point is when p is equal to 1 and t is equal to 2. So t is like our x, so it's 2, 1, and that is our stationary point that we're interested in, because we were only interested in the t values greater than 0. One more, finding the stationary point here. Again, it's a cubic, so we would expect a maximum of 2 stationary points. So let's have a look. dy dx is equal to 3 minus 3x squared, and I'm going to let dy dx equal to 0. So 3 minus 3x squared equals 0. So 3x squared is equal to 3, x squared is equal to 1, x equals plus or minus 1. Now there's no stipulation here on whether x value should be greater than 0, so I'm going to accept both of them. So let's do the first one. When x is equal to 1, y is equal to 4 plus 3 times 1 minus 1 cubed, and that gives us 4 plus 3 minus 1, which is 7 minus 1, which is 6. So one of your stationary points is at 1, 6. The other one is when x is equal to minus 1, y equals 4 plus 3 times minus 1 minus 1 cubed, 4 take away 3 plus 1, which is 2, and your other stationary point is at negative 1 and 2. The curve with equation y equal to x cubed plus ax squared plus bx plus c passes through the point 0, 5 with stationary point at 2, 7. Find a, b and c. So this is not dissimilar to questions we've done previously. We're given really 2 bits of information there. Let's start with the easy bit. We're told that when x is equal to 0, y is equal to 5. So let's do that. So when x equals 0, y equals 5. Let's substitute that in, and we get 5 is equal to 0 cubed plus a times 0 squared plus b times 0 plus c, which works out really nicely there because we end up with c equal to 5. So we now have another point that the graph goes through. It's the point 2, 7. It not only goes through that point, but it's also a stationary point. So let's use that information in two different ways. So using the point 2, 7, when x is equal to 2, y is equal to 7. So you get 7 equals 2 cubed plus a times 2 squared plus b times 2 plus c, and remember we now know that c is equal to 5. Let's tidy that up a little bit. And so the last bit of tidying up there is to divide by 2, so you get negative 3 is equal to 2a plus b. So that is an equation that we can use. Now obviously we've got two unknowns, we need to come up with one more equation. So where do we get the information for that? Well, we're still going to use that same bit of information because we know that there is a stationary point there. So using that information again, but in a different way, we know that dy dx is equal to 0 at x equal to 2. So dy dx, something we need to use and find. So we've got 3x squared plus 2ax plus b. Okay, we know that that is equal to 0 when x is equal to 2, so 3 times 2 squared plus 2a times 2 plus b. 0 is equal to, and when we tidy that up we get negative 12 is equal to 4a plus b. So there is another equation with a and b in it. So it should be now a matter of using simultaneous equations on those two in order to be able to find a and b. So here we can say equation 2, take away equation 1 from our two equations, and 4a take away 2a is 2a. The b's cancel out, and minus 12 minus 3, so it's plus 3, would be negative 9. So a is equal to negative 9 on 2. We now have our a value, so the very last thing we want to do is find our b value. So I'm going to substitute that value into one of those equations, and it doesn't really matter which one. I'll probably just do it into the first one, and so I get 2 times minus 9 on 2 plus b is equal to minus 3. So that gives me minus 9 plus b is equal to minus 3. B is equal to minus 3 plus 9, which is 6. So I now have all three values. I have a is equal to minus 9 on 2. I have b is equal to 6. And I have c is equal to 5. And so I have answered the question. Now, of course, if it was a technology exam, we could use our calculator. So let's have a look down here at what you would need to put into your calculator. You need to define your function. And once your function is defined, then you are going to find the derivative of that at x equal to 2. So that's the first step there. This one is when we let x equal to 0 and y equal to 5. This is when we let x equal to 2 and y equal to 7. And of course, that is that one where you let the derivative equal to 0 when x is equal to 2. And it will give you your three answers. So let's just recap. Stationary points on a graph is where the gradient is equal to 0. If we want to find those stationary points, we let the gradient equal 0, and we should be able to then come up with the coordinate